Okay, well, thank you all for being here. So I'm here to present InSilico DB. This is our website, insilicodb.com. Please check it out, and we have a Facebook page and a Twitter handle. Um, so what we'll do is that we will link individuals and their genomes to biologists and scientists. And the resulting community will accelerate scientific and medical discoveries and will also bring individuals closer to breakthroughs and novel medicines. So as you know, genomics data represents a first step towards a high-definition medical map of every individual. So we can think of it as a digitized human being. And just like a digitized map that has streets and highways and public transport, roadworks, accidents, we need a GPS device to navigate these streets, so just like Google Maps. And we think that the same way we navigate these streets, scientists and biologists will navigate digitized humans. And so how navigation can save our life, so let's imagine that we have our genome sequenced, and we have a team of biologists that looks at our genome, and they find that we are at risk of developing skin cancer. So as a result of that, we go to the dermatologist more often, and we get screened more often, and eventually she finds a tumor, a skin tumor, and she removes it on time. But the problem is that, first of all, even if we had all our genome sequenced, we do not have access to a team of biologists that can screen those genomes and that can eventually tell us that there's a genetic preventive test that we might want to take. So because it's just unaffordable and not possible to go and see every different doctor every month, then we don't do it, and we hope for the best, and for the unlucky of us that are at risk, then we eventually die. And so we think that we need scientists and we need biologists to look at our genomes, and they also need that data to validate their hypotheses and make new discoveries and develop new tests. And so just like a GPS needs millions of topographic points and traffic information to figure out what's the best way to get from point A to point B, then these people need the data to figure out their new discoveries. And the problem is that biologists today in the current environment, they don't have access to this data. And this is because data is huge. The data is scattered all around the place, and they need to move the data. They need to juggle with the results they get from one tool, and they need to push it into another. And for them, basically, it's very difficult today to interrogate the data. And so to answer this, we created InSilico DB. And it's a collaborative genomics hub that makes it possible for biologists to analyze genomes without programming expertise. So we centralize the data, we let data flow in, we standardize the data, we process the data, and we connect the data to existing analysis tools that biologists already use. And so today we have over 8,000 registered users, we have over 400,000 genetic samples. They have been analyzed over 100,000 times, and this has resulted in over 50 scientific publications. Before, basically, the old way is that a biologist needed to ask a question. He would go to a data scientist or to a bioinformatician that would have to look into the data, look into public repositories, aggregate the data, combine it, and then ask a question, and then go back to the biologist, and then the biologist would ask again, and then this was basically a very lengthy process. And today we're seeing that, well, basically these thousands of biologists are asking questions themselves up to a certain level and getting results with the platform. And this is one of our testimonials. So this is Baharia Mograbi. She is from the Cancer and Aging Institute in Nice, France, and what she says is that InSilico DB changed the way they work, and we were the only ones that made them believe that interrogating genomics data was possible. So Well, I'm gonna skip this slide. This is how we did it and how we're allowing people and bioinformaticians and how we're pulling different pipelines into our own system. But what I wanted to show is basically this is our growth rate. How this is how the adoption has been going for us. We started in 2012 with the first prototype. And since then, since 5 months, we started marketing this and targeting biologists, and we've seen over 1,000 new users every month, and we have over 8,000 users today, and many of them are active in the platform. And so basically, my key message here is that we've built and that community of biologists. So we have a large community of biologists, and it's growing. And basically, it's you know with sequencing technique becoming reaching maturity, and with the price dropping so much, basically there is little doubt that during the next decade, billions of people will get genotyped and sequenced. And so what we want is to connect their genomes to this community of biologists to improve their health and their lifestyle, but of course under their own terms. So I'd just like to acknowledge the team that is behind this. We're a small team at the moment. So Robin Duquet is an engineer, comes from the bank industry. James, Jaro, Virginie, Lionel, myself, and David, who's our CEO. This is the timeline of the company. We started, as I said, in 2012. We raised the first seed fund in 2013. We launched the first beta version of the website in 2014. We've been aggregating public data, and we've been adding private data too. And now the next step is to invite people to add their own genotypes and their own genomes. And we'll be doing this at the beginning of next year. So thank you very much for listening, and I'm happy to take your questions now. Any questions? Yes?
What questions are your users mostly asking?
So the question is what sort of questions the user are asking now. So at the moment, most of the data is gene expression data from microarray and RNA-seq. So they're asking for pathways. They're asking differential gene expression. They're asking to see at comparing basically if their own data is, they want to compare their own private data with public data, or basically they just don't, many of them don't have data, and they just want to validate a hypothesis using public data before they go on and do the experiment. We also have, we're also supporting a project in Brussels. So we were based in Brussels. There's 3 genetic hospitals in Brussels, and we're sponsoring a project where they're putting all the data from their patients together. This is for rare disease. And so they're joining the data together on the platform, and so the 3 hospitals can use the other ones as controls for their own tests.
We've got another question.
Is it human only, or do
No.
you have?
No, it's human, rat, mice, yeast.
Is there a way to input chosen genomes from like NCBI or
Yeah.
other resources?
Yeah, of course. Yeah. So we keep adding public data, Geo data, TCGA data, Array Express data, the Broad Institute data. Of course, we don't have all the data, but we keep adding it, and people we get requests, and it grows and it grows. And as I said, we have over 400,000 genomic profiles today, both public and private.
Any final questions? Okay, that's
Great.
great. Thanks very much.
Thank you very much.